So we have this. Any questions on this? Okay. Now, even though this we knew ahead of time, what you might know already what that's going to look like, that this was going to look like a line. Okay. But the process, though, is this is the process you would use to sketch the graph of an equation in two variables. Okay. Namely, if you want to sketch the graph of an equation in two variables, what you can do is make a table of solutions. You know, you would choose X values like I did. For an exam or test, excuse me, for a test or a quiz, the X values I would give you, and then you would have to calculate the Y values. But normally you would choose X values and then get the corresponding points like I did in this table. You know, you choose the X values, get the corresponding points. You would plot those ordered pairs, plot the solutions, that is, as ordered pairs in the Cartesian plane, then connect the dots. You know, connect them together with a curve, with a smooth curve, that is. Of course, as you could probably guess, the more solutions you get, the more points you plot, that is, the more accurate your graph's going to look like. With something like, you know, with computer software today, you could probably plot hundreds of points if necessary. So, you know, I wouldn't ask you to plot 100 points by hand or something like that. So, although you probably could, but wouldn't be fun. Okay, so that's the idea here. Okay, here's another example. We have y equals 4 minus x. Okay. And again, the x values here, I chose randomly. We have -1, we have 0, we have 1 and 2, okay? Now we have these points, x values I chose. Okay. From here, okay, from here, what we do is we get the corresponding y values, okay? You know, get the corresponding y values. And then we get the corresponding ordered pairs, right? So when x is -1, for instance, our y is going to be, we have 4 minus -1, which is 5. 4 minus -1, which is 5. And that gives us the ordered pair, -1, 5, as a solution. That gives us this. Okay, that's what we get here. When x is 0, right? What's y going to be? 4 minus 0, which is 4. So we get y equals 4. And 0, 4 is a solution. When x is 1, y is 4 minus 1, right? We're plugging in, we get 3. 1, 3 is a solution. When you get all these 4 points, you can plot them and connect the dots. That's what I did. Well, Desmos did that. I mean, I didn't plot the last point 2, 2, but you can see it here, right? And if you connect them, you will get a line. Okay? That's what we do here. This here, I actually drew using Desmos, D-E-S-M-O-S, you know, the online graphing software. Let me see if I can find the other one. This one I drew using GeoGebra. Both of them are free. So just letting you know. But again, here we get a straight line. I mean, again, the more points you plot, you know, the more accurate your graph is going to look like. All right. Any questions on that? Here's another one. Let's have y equal to the square root of x, okay? Y equals the square root of x. Okay, so what do we do here? Well, we are going to choose x values. I mean, theoretically, you could choose any x values, although here, as we already know, you can only take the square root of something that's bigger than or equal to 0. Right? You can't take the square root of a negative here in this class, mostly because we haven't done complex numbers. So because of that, the x can only be 0 or bigger. Also, for the purposes of these calculations and graphing, I chose x to be a perfect square each time. With the calculator, I guess you really don't have to do that, but that's what I did here. So anyway, we have different x values, right? We have x is 0, right? Okay. Y is the square root of 0, which is 0, okay? And so from here, what do we get? 0, 0, right? X and y are both 0. So the ordered pair here, the solution we get that's on the graph is 0, 0, the origin. When x is 1, right? Y is the square root of 1, which is 1. Okay? 1, 1. When x is 4, y is the square root of 4, which is 2. Which, of course, is 4 comma 2. That gives you this point, right? When x is 4, y is 2, the square root of 4. When x is 9, that's a perfect square. The square root of 9 we know is 3. So y is 3. This is on the graph. And if you were to plot these points and then connect them, you would get something like this. I mean, here I keep on going. Well, Desmos does, I guess, actually. But you would get something like this. Again, the more points you plot, the better your graph's going to look. But here we have Desmos, so other graphing software, which makes it a little bit easier. Okay, so okay, beautiful, good. Okay. Noticing, okay, so that's good. What I wanted to say. Any questions on this? Okay. Let's keep going then. So here we actually have some special kinds of points called intercepts. Now you can have a graph that intersects the x-axis, right? It's going to pass through the x-axis, or touch it at least. When it does that, okay, when it does that, it'll intersect it at a point that looks something like this, a comma 0. I mean, a is going to be a number. The y-coordinate has to be 0, right? Because if you intersect the graph, the x-axis, right, your y-coordinate has to be 0. The x-coordinate here, the a, that's called an x-intercept of the graph. We call that an x-intercept of the graph. That's what we call it. I mean, a graph could intersect the x-axis, not only just once, maybe more than once. I drew a circle here, as you can see. And what I'm saying here is that the graph is intersecting the x-axis at 2 and 5. 2 and 5, right? Excuse me, at the points 2, 0 and 5, 0. But 2 and 5 themselves are the x-intercepts. 2 and 5 themselves are the x-intercepts. That's what happens here. Okay. Excuse me. Likewise, we also have this notion of a y-intercept. Excuse me. A y-intercept, right? The idea there is the graph will intersect the y-axis, right? It will do that at a point 0b. The graph will intersect the y-axis at a point 0b, because any point on the y-axis has to look like this. It has to be of this form, 0 comma something. That something, that b, the y-axis, excuse me, that number is called the y-intercept. That number is called the y-intercept. I mean, here the circle doesn't intersect the y-axis. We have seen graphs that do that, though. And really what this graph is showing you also is you don't have to have y-intercepts. And you could have more than one, as it's showing with x-intercepts. So a graph could have a y-intercept. It could have more than one. It could have none. Similarly, a graph could never intersect the x-axis. It might intersect it more than once. You know, that can happen also. Okay. Now, how do you actually find these intercepts? Well, you could graph it. You know, you could always do that. But let's say you couldn't graph it for whatever reason. You can solve it algebraically. Essentially, what you're going to do is you're going to set the other variable to be 0 and solve the corresponding equation. So for instance, for the y-intercept, right, you're going to set x to be 0 and figure out what y is. So for the y-intercept, you're going to set x to be 0 and calculate y. For the x-intercept, the other variable is y. You set y to be 0 and solve for x. That's what you do there.